Ladies and gentlemen, welcome to the Hong Kong Convention and Exhibition Centre, and thank you for attending the Shaw Prize Award Presentation Ceremony 2015. I am Dudu Chen, your presenter for tonight.
Good evening. I'm Leon Ko. I'm much honored to be the Master of Ceremonies again for the presentation of this distinguished international award, witnessing the outstanding achievements of the laureates and to share their joyous moments.
Known as the Nobel Prize of the East, the Shaw Prize was established in November 2002 under the auspices of Mr. Run Run Shaw. It consists of three categories, namely the Shaw Prize in Astronomy, the Shaw Prize in Life Science and Medicine, as well as the Shaw Prize in Mathematical Sciences.
The first Shaw Prize Award presentation ceremony was held in 2004. This annual award is now held for the 12th year running. Including this year, 65 scientists have been awarded the Shaw Prize since its debut, enabling a great many devoted and outstanding scientists to be recognized worldwide.
The purpose of the Shaw Prize is to honor individuals who are currently active in their respective fields and who have recently achieved distinguished and significant advances, who have made outstanding contributions in academic and scientific research or applications, or who, in other domains, have achieved excellence. The award is dedicated to furthering societal progress, enhancing quality of life, and enriching humanity's spiritual civilization.
Nomination commenced in September last year and followed by adjudication in the first few months of 2015. The results of the Shaw Prize 2015 were announced at the press conference held on the 1st of June this year. 5 Shaw laureates have been awarded the prize, and tonight they are here to receive the honor.
It is time for the commencement of the Shaw Prize Award Presentation Ceremony 2015. Ladies and gentlemen, please rise to welcome our officiating guest, the Honorable C.Y. Leung, Chief Executive of the Hong Kong Special Administration Region of the People's Republic of China, accompanied by Mrs. Regina Leung. Mr. and Mrs. Leung, please.
Please remain standing to welcome the 5 Shaw laureates to enter the presentation hall. First, please welcome the Shaw Laureate in Astronomy 2015, Mr. William J. Baruki, please.
We now welcome the Shaw Laureates in Life Science and Medicine 2015. This year we have 2 Shaw Laureates. Firstly, Professor Bonnie L. Bassler, please. Next, we have Professor E. Peter Greenberg, please.
Last but not least, let us welcome the Shaw Laureates in Mathematical Sciences 2015. This year, there are 2 Shaw Laureates. Firstly, Professor Gert Fouting, please. Then, Professor Henrik Iwaniec, please. Ladies and gentlemen, please be seated. Invite the Vice Chairman of the Board of Adjudicators, as well as Chairman of the Selection Committees, individually to deliver a speech. Professor Kenneth Young, please.
Chief Executive, Mrs. Shaw, laureates, distinguished guests, ladies and gentlemen. Welcome to the 12th Annual Shaw Prize Award Presentation Ceremony. The 3 scientific fields covered by the Shaw Prizes, namely astronomy, life science and medicine, and mathematical sciences, have all made spectacular progress in recent years. Tonight, we honor 5 scientists in these 3 fields for their distinguished contributions. The Shaw Prize was established in the year 2002 under the auspices of Mr. Run Run Shaw to honor individuals, regardless of race, nationality, gender, and religious belief, who have achieved significant breakthroughs in academic and scientific research or applications, and whose work has resulted in a positive and profound impact on mankind. The first Shaw Prize Awards presentation ceremony took place in 2004. Since that time, including this year's awards, there have been altogether 37 Shaw Prizes awarded to 65 scientists in these three fields. The Shaw Prize is proud to play a role in recognizing revolutionary advances in these vibrant and productive areas of modern scientific research. The chairs of the selection committees will now present the laureates and their achievements. Thank you.
We now invite the chairman of the selection committee for the Shaw Prize in Astronomy, Professor Peter Gowright, to deliver a speech. Professor Gowright, please.
Ladies and gentlemen, it is my honor to describe a little bit about the recipient of this year's Shaw Prize in Astronomy. 30 years ago, William Barucki and Audrey Summers published a paper assessing the potential for detecting extrasolar planetary systems by transit photometry. The key concept is to simultaneously monitor the brightness of a large number of stars with a high-precision photometer. Planets are revealed by the dips in brightness they produce when they pass in front of or transit their host stars. Successive transits by a planet are spaced by its orbit period, which helps to distinguish transits from other sources of stellar variability. Transit depths determine the ratio of a planet's surface area to that of its host star. Barucki and Summers emphasized that detection of Earth-sized planets would require observations from above the atmosphere. Yeah, so you can see an example, a cartoon example of a transit in the figure on your left. Subsequently, Barucki began a long quest to develop a suitable photometer and to convince the astronomical community and the United States National Space and Aeronautics Administration, also called NASA, that a modest space mission could discover planets potentially capable of harboring life. 4 proposals submitted between 1992 and 1998 were rejected before the 5th was selected in December 2001 as Discovery Mission number 10. Mission development began in 2002 and launch occurred in March 2009. 5 years after launch, the Kepler mission has detected over 4,000 planet candidates and confirmed more than 1,000. Analysis of these data shows that most stars have planets and that small Earth-sized planets are common. An important milestone in gaining acceptance for the Kepler mission was the demonstration that photometry from space would be precise enough to detect Earth-sized planets transiting Sun-sized stars. Since Earth's radius is about 1/100th of Sun's radius, this requires measuring brightness variations smaller than 1 part in 10,000. Kepler routinely achieves higher precision, and as a result, has discovered planets even smaller than Earth. Kepler accomplished an important secondary goal, the precise measurement of photometric variations due to stellar oscillations. These are shown for one star in the figure that's up there now. Determination of oscillation frequencies informs us about stellar ages, masses, radii, and internal rotation rates. This is a very big step forward in our understanding of stars. Baruchi's work is an important step in the search for life on planets orbiting stars other than the sun. It's probably going to be a very long path before we get there, and perhaps even longer before we find intelligent life that can communicate with us around other stars. But I'm sure this will ultimately happen. Thank you.
Thank you, Professor Gilwright, and please take your seat.
We now invite the chairman of the selection committee for the Shaw Prize in Life Science and Medicine, Professor Yut-Wai Kan, to deliver a speech. Professor Kan, please.
The Honorable Chief Executive, Mrs. Mona Shaw, ladies and gentlemen. For many years, bacteria have been regarded as individual cells that act independently. Beginning in the past 4 decades, building on the work of Woodland Hastings, Kenneth Nielsen, Michael Silverman, and others, research has shown that bacteria survive and thrive together in communities and communicate with each other and with other species to coordinate functions that are difficult to achieve by individual cells. The communication strategy is called quorum sensing. We are not unlike bacteria. We need a quorum before we can act and vote. Bonnie Bassler of the Princeton University and Peter Greenberg of the University of Washington are awarded the Shaw Prize in Life Sciences and Medicine for their major contributions to the elucidation of the molecular mechanism of quorum sensing. Each bacterium produces chemical molecules called autoinducers that are released into the surrounding. One class of autoinducers the bacteria make is unique to each species of bacteria and recognized by the receptors of the same species. As the bacteria divide and reach a critical density, the concentration of the autoinducers become high enough to stimulate the bacteria to turn on together a similar set of up to a few 100,000 genes. They can then perform coordinated functions such as emitting light or bioluminescence, forming biofilms, secreting toxins, or causing virulence. Thus, the same species of bacteria communicate and form a community. In addition to intra-species communications, bacteria can produce another class of chemicals or autoinducers that are common to and recognized by other species so that different species can communicate with one another. Together, they can collaborate in forming biofilms, refine the resistance, or other function. The phenomenon of quorum sensing is apparently not limited to bacteria. It has been described in certain insects that work together, such as some ants and some bees. A recent report also indicates that it may play a coordinated role in hair growth in a mouse model. The elucidation of the mechanism of quorum sensing by Bassler and Greenberg began with luminescence in marine bacteria and moved on to human pathogens. Many bacteria are human pathogens. Their insight into the mechanism of quorum sensing has spawned new concepts to treat infections in a fundamentally different way from the conventional antibiotics currently used. In view of the continued emergence of antibiotic-resistant bacteria, such alternative treatment are sorely needed, as affecting autoinducer or the receptor in quorum sensing could control the virulence of the bacteria. New classes of chemicals are being actively explored to treat infections in humans, or perhaps even for baldness. Thank you.
Thank you, Professor Ken, and please take your seat.
We now invite Professor Peter C. Sarnik, Chairman of the Selection Committee for the Shaw Prize in Mathematical Sciences, to deliver a speech. Professor Sarnik, please.
Chief Executive, Mrs. Shaw, ladies and gentlemen, it is a great honor and a great pleasure for me to say a few words about the 2015 Shaw Prize winners in mathematics. The theory of numbers is one of the oldest branches of mathematics, and it remains today as one of the most active and exciting areas of investigation. Young mathematicians are attracted to it by its simplicity and the beauty of its challenges. But while the problems are often very easy to state, they are extremely difficult to resolve and very often requiring the most sophisticated and modern tools from all of mathematics. Our two laureates today, Gert Faltings and Henrik Iwaniec, are responsible for some of the most spectacular advances in number theory in the last 30 years. They have been instrumental in solving problems, providing techniques and tools, theories that have become standard for all workers in the field and even in related areas. Gert famously burst onto the scene with his proof of the long-standing Mondale conjecture, which concerns, I didn't bring a blackboard, put the equations up, so I'll just describe it in words. You have a polynomial in two variables with coefficients which are rational numbers. These are numbers which are fractions. And you want to solve the equation for x and y, which are rational numbers. And unless the equation is very special, which we understand very well, his famous theorem is there are only finitely many solutions, one of the most profound theorems in the theory of numbers. Like many new papers with major breakthroughs, this paper resolves a number of other problems at the same time. His many works since then contain similar breakthroughs with the development of sophisticated and powerful tools. His higher dimensional Diophantine approximation theorem and his foundational development of p-adic Hodge theory are two striking examples. Gert has played a major role in shaping the modern theories of Diophantine geometry and arithmetic geometry. Henrik Iwaniec burst onto the scene early on with his works in sieve theory and its application to prime numbers. The theory today is an advanced subject with spectacular applications which come these days actually every few weeks. And these breakthroughs are to a large extent resting on the ideas and tools that Henrik has introduced over many, many years. Henrik's works span most of the aspects of modern analytic number theory, including solutions of many long-standing problems. The analytic theory of modular forms and their L functions is, thanks to his pioneering works, a very powerful and user-friendly theory. One need not look far in almost any of the many recent papers in this area before recognizing Henrik's ideas and insights. Henrik is an anti-sensational person, you probably meet him later, and his style is always to open the door and then leave and let the other people take all the glory. But tonight I see he's getting a great glory. Henrik has played a major role in shaping what we call analytic number theory. On behalf of the Mathematical Sciences Committee, I offer my very warm congratulations to Gert Faltings and Henrik Iwaniec, winners of the 2015 Shaw Prize in Mathematical Sciences. Thank you.
Thank you, Professor Sarnik, and please take your seat. We will now proceed to the Shaw Prize Award Presentation Ceremony 2015.
Ladies and gentlemen, tonight we're much honored to have the Honorable C.Y. Leung, Chief Executive of the Hong Kong Special Administrative Region of the People's Republic of China, to officiate at the presentation ceremony. We will present the Shaw Prize in Astronomy 2015. The award goes to Mr. William Barucki. Professor Barucki, please.
The objective of the mission is to find out whether Earth-sized planets are common in the habitable zone of stars like our Sun. Life is much more complex than anyone ever expected out there, and it's richer.
We now invite the Shaw Laureate in Astronomy 2015, Mr. William Barucki, to deliver his acceptance speech. Mr. Barucki, please.
Honorable Chief Executive Mr. Leung and Mrs. Leung, the Shaw Prize Council, especially Ms. Mona Shaw, Professor Ching Yang, Professor of the Board of Educators, Professor Young, Professor Peter Goldreich, Chairman of the Selection Committee for the Prize in Astronomy, Professor Kahn, Professor Sarnik. Honored guests, ladies and gentlemen, it is truly an honor and a privilege for me to be here tonight and to receive this very prestigious prize in astronomy from the Shaw Foundation. I would like to thank all who have made this prize possible. In particular, I would like to thank my wife, my family, my friends for their unwavering support, and to my parents and teachers who have contributed so much to the person that I am. I'd like to thank the Kepler team members, including the scientists throughout the world who have contributed to the mission and have helped us interpret its data. And to the scientists, engineers, managers, and personnel at NASA Ames, at NASA headquarters, at the Jet Propulsion Laboratory, the Ball Aerospace and Technology Corporation, and the Laboratory for Atmospheric and Space Physics, and to so many other groups that have made the Kepler mission a success. I would like to take a moment to tell you a little bit about the Kepler mission and its meaning. Humankind has always wondered, are there other worlds? And do these other worlds have intelligent life? Are there civilizations among the stars? What is our status among such civilizations? The Kepler spacecraft has taken an important step toward answering these questions. It was designed to determine Earth common or rare in our galaxy. If common, life and intelligent life might fill the galaxy. If rare, we might be alone. Kepler's 4-year search of 170,000 stars shows that the galaxy is filled with planets. In fact, there are more planets than there are stars. Although many of these planets appear unsuitable for life, about 10 billion such planets, about the right size and in a habitable zone where life might evolve, exist. The Kepler results bring about the next important question. Where are these life forms? Why haven't we heard from them? Why has the SETI search over 3 decades not heard any signal? Now is the time for our children and grandchildren to take a step forward and continue this search for answers. Thank you for this most prestigious astronomy prize.
Now comes the Shaw Prize in Life Science and Medicine 2015. This year, the award is shared equally by 2 recipients. The first chair goes to Professor Bonnie Bassler.
How could it be that these itty-bitty little critters could get inside you and kill you. The way it works is they count themselves, they recognize when they have enough that if they all launch their attack together, they can overcome the host immune system.
The other recipient of the Shaw Prize in Life Science and Medicine 2015 is Professor Peter Greenberg. Professor Greenberg, please.
If we can do this, then that will be an impetus to really try and develop medicines that treat, rather than plant infections, human infections. We'll know it can work in some system.
We would invite Professor Bonnie Bassler to deliver her acceptance speech. Professor Bassler, please.
To the Shaw Foundation, thank you. The Shaw Prize validates the importance of the research that together the members of the quorum sensing field have pioneered. For bacteria, quorum sensing is about the group getting more than the individual. In my lab, scientists also work together so that the group gets more than the individual. The Shaw Award inspires me and my group to pursue our dream to develop new medicines to combat disease-causing bacteria and devise strategies that help beneficial bacteria have a more positive impact on the world. I started in this field on an impulse when, at a small conference in Baltimore, Maryland, Michael Silverman revealed how he discovered and characterized the components of the first quorum sensing system. My curiosity was ignited. I asked to work with him as a postdoc. He said yes. Mike Silverman inspired discovery and creativity. He taught me to be an adventurer. He is my hero. Princeton University took a chance on me before the quorum sensing field was established. The NSF, the ONR, the NIH, and the Howard Hughes Medical Institute funded my work. Collectively, those groups gave me what I needed to do it. It is an honor to live a life of discovery, and I know it. I spend every day with superstars in the making who come through my lab with the singular plan of going on a collective risk-taking intellectual adventure to change the way we understand the world around us. I always thought the best part of being a scientist would be making the discoveries, the aha moment, but I was wrong. The best part of my career is the group of people I work with who make the discoveries. I am a voyeur of their aha moments, and it is thrilling. I thank all the members of the Bassler Lab for your jaw-dropping accomplishments. I am standing here for you. We did this together. This is our award. Finally, but not least important, is my husband, Todd Reichert. He is my biggest fan. He always tells me I can do it. He also cooks all of my meals. Todd, you are one of the most essential members of the quorum sensing field and of the Bassler Lab. We did this together. This is our award. Thank you. Thank you.
Thank you, Professor Bassler. Please take your seat on stage.
We now invite the Shaw Laureate in Life Science and Medicine 2015, Professor Peter Greenberg, to deliver his acceptance speech.
It's with great pride and humility that I accept this honor. I thank the Honorable Chief Executive, the Council, the Board of Educators, Professor Kahn, and the Selection Committee in Life Sciences and Medicine, and Lady Shaw. I have to thank the many fantastic scientists who've worked with me over the last 35 years. My training philosophy is to attract bright young minds to our group and then try my best to stay out of their way. I thank my family and friends, particularly my wife, Carrie, for undying support. We have a quorum of family here tonight, and I appreciate their support more than they will ever know. My story begins in 1973. I was a graduate student, and I just learned about luminescent marine bacteria and how they only make light when they're in a crowd, when they're in a laboratory culture vessel and they get crowded. I wanted to work on how they knew they were in a crowd. It seemed like a kind of communication to me, and it coordinated a social activity, light production. We can see the light produced by a group of bacteria, but we can't see the light produced by only a few individuals. The cells cooperate to make visible light. This was just fantastic to me, bacterial communication and cooperation. So after graduate school, I went to work with the guru of bacterial luminescence, J.W. Hastings. This was in 1977, and then I started my own research program in 1979. In the early days, there was a very small group of labs working on the problem, but we learned how light was controlled, how light production was controlled. The field really turned in the 1990s. This was not just some strange phenomenon restricted to luminescent marine bacteria. For our part, we identified quorum-sensing signals produced by a human pathogen, a bacterium called Pseudomonas. And this opened a door. This bacterium became our new model. Critical details about how the system works rushed out, and new investigators rushed in. This was also when we coined the term quorum sensing. Today, there are hundreds of scientists working in our field, and we're beginning to harness bacterial sociality to control diseases and for environmental applications and more. As I said, I accept this great honor with humility, and I accept it on behalf of the many people who I represent. Those are my students and my colleagues. Thank you.
Lastly, we will present the Shaw Prize in Mathematical Sciences 2015. This year, the award is shared equally by two recipients. The first share goes to Professor Gert Faltings.
I first was interested in physics, but then I liked more mathematics because things are either true and false. It's not a matter of opinion. To me, it was clear that I had some talent.
The other recipient of the Shaw Prize in Mathematical Sciences 2015 is Professor Henrik Iwaniec. Professor Iwaniec, please.
See people using your concepts without even, mentioning it, because nobody even know where it actually originated from. But you may see a trace of you a little bit. That's great pleasure.
We would invite Professor Gert Faltings to deliver the acceptance speech. Professor Faltings, please.
Dear Chief Executive, dear Mrs. Shaw, dear members of the board. So I won't try to explain to you the Mondale conjecture. I will speak a little bit about mathematics in the perception of mathematics. For us as mathematicians, it's easy to love mathematics because it pays our bills. But for the general public, people are not aware that mathematics has developed from simple calculation to using more concepts. And usually if I tell somebody that I'm a mathematician, he starts answering that he was already bad at it at school and was glad that he had finished with it. And also mathematics is not considered really useful like medicine or physics. This is, for example, one reason why there is no Nobel Prize for mathematics. But so that the Shaw Foundation gives a prize for mathematics, show that they also appreciate useless things, and I think we are very much honored by it. I should also mention that, of course, I profited from work of others, and unfortunately, some of the people I would like to have with me are no more alive. The first of them is my wife, Angelika, and the second of them is my teacher, Professor Nostold, who early believed in me and told me what to study. Finally, I should say something about, of course, I'm thankful for the prize. People sometimes ask me whether I'm proud, but I think that proud is not the right word, because proud you can only be of something you worked for. And for the prize I didn't work for, I got it unsolicited, and it's a gift, and the foundation doesn't expect anything in return. So I think I'm deeply touched by this, and so I thank the foundation again.
Thank you, Professor Faltings, and please take your seat.
We now invite also the Shaw Laureate in Mathematical Sciences 2015, Professor Henrik Ivanovic, to deliver his acceptance speech. Professor Ivanovic, please.
Mr. Chief Executive, Mrs. Mona Shaw, and the Shaw Prize Foundation, the Board of Adjudicators, the members of Selection Committee, and distinguished guests. I'm very happy to accept the Shaw Prize Award for 2015 in Mathematical Sciences, and it is with great pleasure that I share it with this award with my colleague Gerd Faltings. This exceptional occasion is we both work in the theory of numbers, and the award for both of us confirms the significance of our field. Great mathematician and astronomer Carl Friedrich Gauss said, "Mathematics is the queen of the sciences, and number theory is the queen of mathematics." As I love prime numbers, I hear the music of primes in Gauss' words. In fact, all mathematics is amazingly musical. Its harmony arises out of numbers, like musical scales by means of ratios of integers. Learning and creating mathematics is an intellectual joy. I have experienced it already in high school when I tried to prove the famous theorem of Dirichlet about prime numbers in arithmetic progressions. Well, I didn't succeed, but it stimulated my great passion to this subject. Many years later, my friends and I achieved deeper results. Our results exceed implications of the Riemann hypothesis. And the Riemann hypothesis itself is probably the most celebrated open problem in mathematics. So I feel today reborn because the selection committee praised our results in the citation. My achievement wouldn't be possible without sharing ideas and receiving inspiration from many of my colleagues. So I thank them all, in particular to Enrico Bombieri, John Friedlander, Jean-Marc Desier, Etienne Fouvre, Peter Sarnak, Brian Conray, and William Duke. During my entire career, I have received numerous encouragement and support, beginning from dedicated teacher in high school in my native town, Elbląg in Poland, and also from Professor Andrzej Schinzel during early years of my study and development. But my dear family was constantly supportive throughout my career, which gave me the strength. Unfortunately, my wife, Kasia, couldn't accompany me today because of her injury in a recent accident. However, I'm very happy and proud today to be with my younger daughter, Professor Anna Iwaniec-Hickerson. So I thank the committee for choosing me for this very prestigious and generous award. I also thank the Shaw Prize Secretariat for organizing this wonderful, memorable event. Thank you.
We now invite our officiating guest, the Honorable C.Y. Leung and Professor Laureates, to stay on stage for a group photo. The Shaw Prize Award Presentation Ceremony 2015 has now come to a successful conclusion. Scientific research has embedded boundless possibilities. We look forward to seeing you again next year and to witness more accomplishments of distinguished scientists and scholars. Good night, goodbye, and see you next year.
Thank you. Goodbye.